Assalamualaikum warahmatullahi wabarakatuh. Hello, the honorable ladies and gentlemen. On this very good occasion, I'd like to present about the research paper entitled Transfer-Learning VGG16 for Image Classification of Tomato Leaf Disease. First of all, allow me to introduce the authors of this paper. I'm Elsa Dundur Ifati, a student of Informatics Engineering in Muhammadiyah University of Magelang as the first author. There is Mrs. Maimuna MSA MCom, Lecturer of Informatics Engineering in Muhammadiyah University of Magelang as corresponding author, Mrs. Priti Sukmastia Ascom MCom, and Mr. Reza Arif Widianto MCom, Lecturers of Informatics Engineering in Muhammadiyah University of Magelang as third and fourth author. Tomatoes, or Solanum lycopersicum, are one of Indonesia's mainstay horticultural commodities that are exported throughout Southeast Asia. However, the export value of tomatoes in 2021 recorded a decrease of 34.07% from 2020. The decline in the quality and quantity of tomatoes is generally caused by bacteria, fungi, viruses, and mite outbreaks that mostly attack the leaf, such as leaf blight and two-spotted spider mite. The common tomato disease is leaf blight caused by the fungus Phytophthora infestas mondobori, which thrives in cool, moist places, and the two-spotted spider mite disease originates from Tetranychus urticae spider mite outbreaks as a result of excessive insecticide use. The characteristics of infected leaf tend to be similar, making it difficult for ordinary farmers to identify them. Astinum et al. 2020 in their research wrote that plant identification can be done through detecting the shape and texture of leaves through image processing. One of the image processing methods that can handle image classification well with significant results and is very suitable for large amounts of data is the convolutional neural network or CNN with the VGG16 transfer learning architecture because it has a simple structure and can be modified layer architecture to adjust the model and improve its performance. The novelty of this research is modified layer architecture of the VGG16 model by adding a fully connected layer, namely dropout with a value of 0.5, and scenario treatment models with callback function and models without callback function. This research classifies tomato leaf disease via the CNN method, where the VGG16 architecture is used to maximize the performance of the classification model and over 5,176 tomato leaf images, so that the classification accuracy obtained is maximum and accurate. This research is expected to be a reference for learning the CNN method with a transfer learning model in future research, and it can also help farmers in identifying tomato plant disease so that later farmers are expected to carry out prevention and further treatment of tomato plants. And there are several stages in this research to classify tomato leaf disease with the VGG16 type learning model as shown in figure 2. Each stage is explained as follows. Image acquisition. The dataset used for the classification of tomato leaf disease in this study is secondary data of tomato leaf images obtained from Mahesh Babu's Kaggle, which has been updated in June 2022 under the name tomato leaf disease with a size of 200 by sorry I mean um, with a size of 256 by 256 pixels and has a JPG format, and it's labeled tomato healthy, tomato lead-like, and tomato two spotted spider mite with details in table 1. And the stages is preprocessing. The first stage of preprocessing was carried out by resizing the image to a fixed size of 224 by 224 pixels, then extended to the green channel and bring out hidden features with contrast limited adaptive histogram equalization like figure 6. And then in a table 2, shows the percentage split of the dataset that has been labeled with feature X and label Y. The data type of the X feature is converted to float 32, while the Y label is converted to categorical format. Golami et al. 2018 in their research wrote that the split data with the percentages in table 2 gives the best result according to the empirical analysis. And the next stage in the pre-processing process in this research is augmentation with the aim of avoiding overfitting that may occur. In the study, the risk parameter used is 1/2055. The image rotation degree range is set as 15. The shear transformation in the image is determined with a range of 0.1, and to zoom in the image is determined with a range of 0.2. To perform horizontal and vertical image shift, the width shift range and height shift range are set to 0.1. Furthermore, horizontal flip and vertical flip are set to true with nearest field mode. Thus, the lift images for training the model will be more varied. And the 9 augmented images are shown in figure 8. The next stages is classification with VGG16. This research uses the transformer model VGG16 to improve the accuracy of the model without its training time. The convolution and polylayer architecture in VGG16 is deeper than the simple CNN architecture is shown in figure 4. The next stages is model evaluation. The model that has been trained in the evaluated with a confusion matrix based on criteria and equation. A. Precision is indicates the ratio of correct positive predictions to total positive predictions. A high precision value means fewer round prediction errors. And B, as a recall, it's the ratio of correct positive prediction to all observation is the actual class. A high recall value means that the model correctly identifies more actual positive observation. And point C is F1 score. It harmonious average of precision and recall with the function of providing a balance between precision and recall. And the last stages is deployment. The classification model that has been trained is the stored and deployed. Deployment is intended to make it easier for users to understand the process of identifying healthy tomato leaf, lead plague, and to spot a spider mite by utilizing tomato leaf images. Deployment in Python is done by creating a graphical user interface application using Qt Designer so that the application design is more flexible, including image input and accuracy results on image such as figure 5. Next is research result. First is classification result. The training process in this study uses the training process in this study uses 30 epoch parameters, SGD optimizer, learning rate 0.001, and loss function with category cross entropy. A large number of epochs does not guarantee a better model, so the number of epochs can be reduced to shorten the training process. In this study, two scenarios were used, namely scenarios A without a callback function and scenario B with a callback function, which is a function of AI to stop the model when it reaches the best accuracy of the model. Table 4 shows the SA training process where the model stopped at the 30th epoch. This shows that the model is updated 30 times after going through all the training data until the validation accuracy as the model accuracy is 96.27% and the validation loss is 13.35%. Whereas in SB, the callback function is given a provision if the validation accuracy value is greater than 98.50%, um, the messages accuracy fulfilled will be printed so that the validation and loss plots are stopped at the 19th epoch with a validation accuracy in 99.03% and a validation loss of 2.83%. This is because the callback function in SB sets the stop training attribute of the model object to true. Thus, the training process will stop when the desired accuracy has been achieved. Thus, the callback function affects the accuracy value of the resulting model. And the next is model evaluation. Model evaluation with precision, recall, and F1 score metrics can be seen in Table 5 and Table 6. Both tables show that the precision, recall, and F1 score values for healthy tomato, black tomato, and two-spotted spider-mite tomato labels are close to 1. Anyway, evaluation of the model is also visualized with a conversion matrix to compare the predicted label with the actual label and as an illustration of how well the model works and it can be used to calculate its performance measure. And a classification report of SA and SB shows that precision, recall, and F1 score values of the three labels are almost close to 1, which means that both models have good performance. However, the precision, recall, and F1 score values of SB with callback function are higher than SA without callback function. Also, the prediction error of SB is only 15 images, while SA reaches 58 images. Thus, SB is a better classification model than SA. And the next is deployment. The model stored and deployed is the scenario B or SB classification model, which is a model with a callback function that produces better accuracy than the scenario A or SA classification model without a callback function. And the deployment view of tomato leaf disease classification can be seen in figure 11, and the prediction result on the input leaf images as shown in figure 13. There is a description of the percentages of the three detected leaf label. The percentage of tomato healthy shows a greater value than tomato lead plague and tomato spider mite, so the leaf image is identified as a healthy leaf. And we can see that table 9 shows the test result on 7 images of how the tomato leaf with SA and SB. Based on the result, SB produced one prediction error, where the healthy tomato leaf is detected as a tomato 2 spotted spider mite with a fairly high probability value. And then in table 10 shows the test results of 7 images of tomato leaf with SA and SB. And based on the test result, SE produced for misprediction where one images was detection as tomato two spotted spider mite and 3 images were detected as tomato healthy with a high probability value. And the next in table 11 shows the test result of 7 tomato 2 spotted spider-man leaf images with SA and SB. Based on the test result, both SA and SB successfully predicted the image as tomato 2 spotted spider mite. So, from the result of testing 21 tomato leaf images from three labels, both SA and SB models, are able to provide prediction of tomato healthy, tomato lab-like, and tomato spotted spider mite with a fairly high accuracy. However, SA, a model with a non-callback scenario, made for errors in the tomato lab-like test, while SB, a model with callback, only made one prediction error in the tomato healthy test. The magnitude of the probability value produced in the SB model is more specific than that of SA. Thus, the SB model is better at predicting both tomato healthy leaf and tomato lab-like and tomato spotted spider mite. So, in the conclusions, based on the training and evaluation of the model that has been carried out, the model with the callback function is able to produce an accuracy value of 99.03% with precision for the labels tomato healthy as a 0.99 and tomato lab like as a 1.00 and tomato 2 spotted spider mite 0.98, and the number of incorrectly predicted images is only 15. This shows a higher value than the model without the callback function. And then the use of green channel and CLAHE and augmentation in preprocessing can provide a variety of datasets in the model training process and make the image clearer. The model modification made in this study also improve the performance of the model that use of non-callback model scenarios and callback models also affect the accuracy value or the resulting probability value. In testing 21 images from three labels, it shows that model scenarios with the callback function provides more accurate and specific prediction result compared to the non-callback model. The use of CNN method and VGG16 transfer learning is certainly very effective in image processing. Um, the simple and modifiable architecture of VGG16 can improve the performance of the model to adapt to different datasets and produce a more accurate model in predicting image level. The honorable ladies and gentlemen, I think that's all about my risk paper. I would like to say thank you for your attention and see you. Wassalamualaikum warahmatullahi wabarakatuh.